Imagine you're walking outside. Maybe you saw a friend of yours and you want to say hi. As you're walking over there, all of a sudden you trip. Or worse, you trip and fall. Now imagine if someone more vulnerable was to be in this situation. Stakes would have been much higher. For older adults who are 65 years or older, falls are the most common reason for injury related deaths, and over half of falls are caused by tripping. But how do we trip? A trip is likely to occur when an obstacle interrupts the trajectory of the foot mid-air. Guidelines for the City of Toronto allow vertical level changes in sidewalks for up to 13 millimeters. But is that really safe? For example, in this case, maybe the trip occurred because she did not notice the obstacle. If the obstacle was bigger, she could have adjusted her gait and therefore avoided the trip. We can answer this question by monitoring the population's gait. As we're walking, there comes a time where the distance between our foot and the ground reaches a local minimum. This distance is known in the field as the minimum foot clearance. Research has shown that if a trip occurs around this point, the chances of this trip turning into a fall are highest. The problem is, the existing literature mostly looks at this parameter in controlled lab environments, which doesn't reflect the real-world values. That's why we have designed a system that's capable of monitoring this parameter in the real world. The system gathers video data from pedestrians and uses computer vision to automatically analyze the video and extract their minimum foot clearance values. It is capable of large-scale data collection and analysis. In the future, we plan to use this system to analyze data from 1,000 pedestrians so that we can determine the size of obstacles that can put vulnerable populations at risk, hoping that we can have safer and more accessible sidewalks for everyone.